So we're going to see about that transient response. So transient analysis, RL, RC and RLC, and Laplace domain analysis. Okay, transient response, RL, RC and RLC series circuit of these three. What is the derivation? The same derivation answer at the end you have, we will going to found about that I of t. Okay, you have the fourth step. At the end of the fourth step, you will going to found about I of t. Okay, what is the answer you got? The same answer you will going to get through Laplace domain method or analysis method you will going to use to, you will going to get the same answer. That's all. Okay, in the transient analysis recap, let's we go ahead. Okay, what we were seeing. So series connection of the RL, RC and RLC. That's all. Only three things. Okay. So I will going to draw what is the series connections, resistance and inductance. It is connected in series. This is RL, R and L. Then RC means what? R and C. This is RC. Then RLC means what? R, L and C. Okay. So this is a RLC. So this is a series connection of RL, RC and RLC, three things, three circuit. Okay. So transient analysis, generally what is the transient analysis means? It will going to move from one state to another state. Okay, that's all. It is a linearly increases circuit diagram. It is move from one state to another state. Here you may be write about I. Here I will going to write about the time period. So that I is move from 0 to this period, this time period. This is called a transient step. After that one you will going to draw steady state, means constant, that is the time is a constant with respect, okay, current is a constant with respect to the time. So that's why it is called a steady state. Okay, let's we go ahead about that transient analysis. Okay, in the three circuit, okay, there is a model, there is a major two model available. Okay, about the problem solving we were seeing about the three model. What is the major two model means? There is a switch wise, there is a two model. Okay, switch wise there is a two model, one switch, two switch. There is a model wise I will going to classify. One switch is there and two switches you can use. Like I will going to classify in the model one switch diagram and two switch diagram. What is the meaning of the one switch? I will going to draw about the switch here. Draw the switch here. Draw the switch. Only one switch, and the next one, okay, connected to the source. I will going to connect it to the source. So this is a one model. Okay. DC source is excitation. So you will going to excited with help of the DC source. That is about the DC source excitations. So this is about the model number one. Only one switches are there or not? Yes, only one switches are there. DC source is a present. So this is the model number one, DC source excitation. Okay, model number two, when you go to here means two switches are present. That's why two is written here. Two switches are present. So same circuit you will going to draw once again. For example, resistance RL, I will going to draw R with respect to L. I will going to come to years, and here is a, what is that one switch is there. Okay, I will going to draw the switch, and with respect to the source, DC source. Okay, and close it, and here, okay, red. Okay, here another switch. Okay. Okay, so this is about the circuit diagram. What is the circuit diagram? It will going to say, okay, here is a one switches, here is a, I will going to write R L. Okay, here is a, how many switches are there? Two switches are there. You can give the name A or one you can give, and B. So this is a model number two. Okay, so this is a model number two. Okay, like is that this circuit is a further, it will going to change it. So further it is a, what is the possibilities changes. You have, that is model number three. Model number three in the problem it is available. So RL circuit, in the RL circuit I will going to draw that one as well, two switches, switch number A with respect to the DC excitation. Okay, and here change the color. Switch number B I will going to write, and with respect to the source, what is the difference between this one and this one? Here is a B switch. In the B switch no sources are there. Here is a switch B, here is A. So what is it is a model number 2, model 2. Okay, model 2. This is a model 3. I have seen in the I have solved you problems. So 3 model of the problems. So this is a model number 1, only one switch, and then DC excitation. Here is model number 2. Okay, here is a 2 switches. There is a A switch, B switch, A switch, B switch is there. What is the difference between the model number 2 and the model number 3 of the problem means? Even the B switch, no DC sources are there. It is a name is called free source or undriven. But here is a DC source is there. So like about that, two classification is there. Okay. So what to do? So you have that one 4 steps. You have this 4 steps to you will going to solve this problem. Here is the what is the method? Here is a switch is A is present or not? A is present and B is present. So you have the step number 0, comma 4 steps. So totally how many steps? 5 steps. Totally 5 steps you need to concentrate. Step number 0. Step number 0 is coming to the role. Step number 0 is coming to the role. In the step number 0, what you will do? Step number 0, you will going to find out the I. Step number 0, you will going to find out the I. What is I? What is the step number 0? A switch only closed. In the A switch only closed, find out the I. So in the I, okay, what is I formula? Ohm's law. I is equal to V by R formula. Ohm's law it is saying V by R. Okay, V value, substitute the V value and R value only substituted. Why I don't want to substitute the L or C? Because at the time of closing the switch A, inductance is not any energy. It is not getting any energy. So that's why you remove or you will going to omit the inductance and capacitance. Then you will going to find out the I. This is the equation number 0. This equation number 0, once you will going to find out, then you will going to substitute. Then you will going to substitute into the equation number 4. That's why I will going to mention the here 4. The fourth is important here. So equation number 4 you will going to substitute. So equation number 4, what is the equation number 4? You will going to substitute the I value. I value is equal to this answer value. Substitute T is equal to 0. So that's all. You will going to substitute. This is a point you will going to keep in your mind. Okay, because of that 2 switches are present. What about this cases? This cases is a for step number 4, T is equal to 0. I is equal to 0, you will going to substitute. This is step number 4, you will going to substitute on that in this case. Okay, what is this case? Only one switches are present and the DC sources are excitations. Here 2 switches are present means this is a rule. Okay, so once again I will going to repeat you, please listen clearly. So what is that one? What is the difference here? 1, here is a 2, that is a difference. What is the 1? 1 means only one switches are present. Okay, only one switches are present. So how many steps? 4 steps. Step number 4, what? T is equal to 0, I is equal to 0. Then substitute as usual, we will going to find out the I, final I of T we will going to find out. What about this one? So 2 switches are present. 2 switches are the present. Switch A and switch B. 2 switches are the present. If 2 switches are present means how many steps? Step number 0 is present here, comma the 4 steps you will going to proceed. Okay, step number 0 and 4 steps. Okay, then step number 0, what he will do? Switch number A only close. Switch number A is closed means source is connected to the resistance only. Okay, inductance is omitted. Why do I want to omit? Because at the time of closing, okay, inductance is not getting any charges, only resistance, only flow of the current. So that's why D and R only considered to find out the I value. Okay, I found the I value. What to do next? That I value is the equation number 0 you will going to write. That 0 of the equation you can substitute into the 4th equation. What is the 4th equation you will going to substitute? T is equal to 0, I is equal to this 0th equation you can substitute. Previously T and I both also 0, but here is I is not 0. Okay, so this is a point you will going to keep in your mind. Then what is the further we want to see here? So what are the 4 steps you will going to see? What are the 4 steps? Step number 1. So it has that one 4 steps. So step number 1, what is the step number 1? Step number 1 is a KVL, Kirchhoff voltage law. Kirchhoff voltage law means what? V is equal to VR plus VL, that's all. That is about the Kirchhoff voltage law. Okay, then what to do next one? You will going to compare. That is a step number 1, it is equation number 1. Then second one is a compare with that one. Okay, this equation number 1 you will going to compare with a d, okay, dx by dt plus dx divided by dt plus px, p into x, it is equal to q. So you will going to compare to find this is equation number 2. So you will going to compare to find out the p value and q value. What value? P value and q value. What to do? Equation number 1 and equation number 2 comparison. P place what is the value, q place what is the value. Okay, you will going to find out the p and q on the step number 2. Okay, then what to do on the step number 3? Substitute into the equation. Which equation do I want to substitute? It is a questions. See your circuit. In your circuit, DC source is a present means that is a non-homogeneous equation. If DC source is a present, yes or no, DC source is a present means you will going to substitute into the non-homogeneous equation. I of the equation available, you will going to substitute. In the non-homogeneous, 3 places P will going to present and 1 place Q is present. That is the equation number 3. Then next one, what to do? Then after substituted, fourth equation, t is equal to 0, I is equal to 0, substitute. T is equal to 0, I is equal to 0, you will going to substitute. So substitute to find the answer, that's all. That answer is called the final I of t. So this is the 4 steps. What is the step number 1? KVL. Step number 2, comparison. Compare to what you will going to find out? P value and Q value. Then step number 3, non-homogeneous. Why non-homogeneous? That is a question. Why non-homogeneous? Why non-homogeneous means source is a present. In your circuit, source is a present means you can compare with the non-homogeneous only. Okay. If no sources is present, if no sources are present means you can compare with the homogeneous equation. You will going to compare with the homogeneous equation. Okay, that is only differentiation. Okay, it is also 4 steps. What is the 4 steps? The same. First step same, second step same, third step only differentiations. No sources are present, then this model 2 no sources are present means compare with the homogeneous. Okay, this model 3 sources are present, what to do? Go to this one, non homogeneous only. Step number 4. Okay, in the circuit only one switch. So step number 4 is a t is equal to t is equal to I is equal to 0. Both also 0. But in this model number 2 and model number 3, I is equal to equation 0. So that's all. So this is a derivation. In the same method you can completed. We were completed about the derivation and the problems. So we were discussed. And the final I of t we found. Okay. Okay, the same I of t answer we're going to find out through the another method, that is called a Laplace domain method.